After understanding the basic concept of dynamic multi-point VPN, now I'm going to perform practical on Cisco gear to understand very well of dynamic multi-point VPN. So in previous section we have gone through this document, what is the advantage of dynamic VPN and how does it work. So in this section I'm going to use phase 1 configuration. In phase 1, as we know, we have some sorts of problem, and phase we pick out based on our requirement. We can configure phase 1, phase 2 and phase 3 as well. So it is up to us. And I would like to show the topology which I am going to use. In this case, I have a 4 router, hub, spoke 1 and spoke 2. You may have more than 2 spokes. In my case, I would like to make it simple. That's why I'm using only 2 spokes right there. You may have more than it. Another is another router which is working as a cloud or working as a ISP. So make sure you do have a connectivity with ISP, you do have an internet connectivity to all your remote site as well as hub, and then after they can send and receive traffic from the interface which is connected to the ISP and the interface which is connected to the another ISP or a same ISP of another spoke or another site, I should say. So in this case, this router going to work as a cloud. Make sure you have underlay connectivity as I told you earlier. So because we connected with the internet, we get IP address from the ISP which is assigned to these interfaces. Because IP address is public, so they public IP address, so they can be routed through backbone or internet. So we have a underlay connectivity from one end to another end. Then after we going to create a virtual interface or a tunnel, I should say, from spoke to the hub, or sorry, hub to the spokes. So hub going to create a multi-point GRE tunnel facing direction of spokes, spoke 1 and spoke 2. In phase 1 spoke, they cannot send data directly from one spoke to another spokes. In order to send directly data from one spokes to another spokes, we need to configure phase 2 or phase 3, which we're going to discuss in upcoming video. Along with this, I have, let me use black color, I have 20.20.20.x underlay address, network 0, network 4 and network 8. But in reality, in real practical, you may have a different IP address. So I would like to make it very simple to understand. This router is working as ISP, hub, spoke 1 and spoke 2. And this 4 router is running 15.2 iOS. So I'm mention here iOS version because of you may have little bit different command that which I'm going to execute. So now let me move to the configuration script because it makes sense to understand very quickly. This is phase 1 configuration and without any encryption. I'm not going to implement IP security on top of it. So we know mean of tunnel interface and then IP address. I don't need to discuss about this because we have gone through already in GRE tunnel. So this, let me use my marker. These two command which you know already very well. Obviously IPMTU, so we need to tune maximum transfer unit of packet because there is some sorts of header or header overload, so we need to tune our MTU. This is going to be the source tunnel interface that we know in GRE, that we discuss in GRE, but you can see there is no destination tunnel, tunnel destination address, because the tunnel destination is The tunnel destination is, sorry, there is no tunnel destination on hub. Spoke have tunnel destination because this tunnel going to become a multi-point tunnel. So tunnel mode GRE multi-point. So IP address of tunnel in IP next hop resolution protocol authentication Cisco. This is optional. If we want to secure resolution from server to client, we may use the authentication on NHRP. IP NHRP map multicast dynamic. IP NHRP network ID, which is you can pick any of anyone, but in my case I'm going to use 99. As we know, the tunnel source address or source IP address, tunnel mode GRE multi-point, tunnel key, because you may have a multiple logical interface. Actually tunnel is a logical interface, so you may have a tunnel goes to this direction, but at the end you receiving all traffic on your physical interface. It could be serial, fast ethernet or gigabit. So how your router going to differentiate those traffic? So traffic going to differentiate using the tunnel key. So maybe tunnel key 10 for this tunnel 101 for tunnel key 101 for tunnel 2, and tunnel 0 for 10, and so on and so forth. So this is going to identify based on the tunnel key. So IP address, authentication in order to make secure resolution, IP NHRP map multicast dynamic, IP NHRP network ID, which is supposed to be exactly hub and spokes. And now let me go through the configuration. So this is the topology and I have my console window. So before going through any configuration, I would like to show you my interface. So this is the hub, which has 20.20.20.1. This is belong to network 0. Spoke network belong to network 4, and spoke to network 8. Along with this, I have also created a loopback interface which is going to emulate as a LAN, and this is the ISP. So we don't need to configure anything on ISP router. That's why I'm going to clear this off, and let me show IP route or routing table. So basically, if we have internet connectivity, we have default route direction of ISP router. So all those router, hub and spokes, they have default route to direction of ISP. And last thing which we need to check out, do we have a connectivity? So this is 20.20.20.2, which is NBMA address of ISP, and network 4 has IP address 5, 6, 8 has 9, and then after 10. So as we can see, all the router have underlay connectivity. Once we have underlay connectivity, now we can go through, create a tunnel and assign overlay connectivity or assign overlay IP address on top of internet. So I'm going to use a script as well to make to make the configuration simple. This is hub configuration. So on hub, configure terminal out of all. Likewise, spoke. In spoke there is little bit different. So I would like to go through the understanding to make you understand the command. So this is the IP address, IP NHRP authentication Cisco, that we know very well. Who is NHRP server? So NHRP next hop server is 10.10.10.1, which is the private IP address of tunnel interface, or tunnel have actually the private IP address, I should say. So this is the IP address of hub, which going to work as a NHRP server, and spokes going to work as a client. IPMTU, IP key, but spokes have point to point tunnel facing direction of hub. So I know where to send traffic, which is 20.20.20.1. This is the destination address of tunnel. So we can say this is point to point tunnel, as well as IP NHRP map. So we're going to perform static mapping first. If we want to talk to 10.10.10.1, who is working as an NHRP server, please send data to 20.20.20.1, which is NBMA, or non-broadcast multi-access address, or address which is assigned by the ISP. This is the physical interface IP address of router. An IP NHRP map, in order to send multicast traffic, again I am sending to the same destination. Likewise, network ID, and as I have discussed earlier, who is an NHRP server or next hop server, 10.10.10.1, source tunnel, and then destination, key, and MTU. Same thing going to be on spoke 2. The difference is that the IP address 10.20, and rest of configuration going to be the same. So let me copy this script. Excuse me. Use Control C, hop over spoke 1, copy on it. Likewise, spoke 2. Excuse me. Let me close this one. So this is the configuration which we need to paste on ISP2 router. Excuse me, this is not ISP2. I forget to mention IPMTU. So interface tunnel 0 IP MTU 1400. This is spoke 2, spoke 1, and hub. Now it's time to verify the dynamic VPN out all router. So let me exit out all the router and then execute so DMVPN. On hub we have two peer 1 and peer 2. Their NBMA or public address is 20.20.20.5 and 20.20.20.9, and their private IP address is 10.10.10.10 and 10.10.10.20. In attribute we can see D, which stands for the dynamic created tunnel. If we move to the spokes, we created the static tunnel, or static resolution I should say. This is what the problem in phase 1. We cannot send direct traffic from one spoke to another spoke. First we need to send the traffic to hub, and then after we can send to the spokes. So let me send some sorts of packet. Before packet I would like to show IP NHRP detail. So these are the IP address which we connected with, or they have registered their information, their private IP address and their public IP address as well. So let me ping 20.20. Now this is going to be 10.10.10.10, which is spoke 1. We do have a connectivity, 20 as well. Similarly, if we're going to ping 10.10.10.1, and 10.10.10.20 we do have a connectivity spokes as well, but we do not have any sorts of routing. We created tunnel from hub to spokes and spokes to hub. Now spokes have point to point tunnel, but hub has multi-point tunnel. So the next thing is what? Let me send traffic from the spoke, one spoke to another spoke. So they are going to send traffic to the hub and then after to spoke. So going to do trace route 10.10.10.20. We can see 10.10.10.1 and then after 10.10.10.20. Likewise, we can also go through other spoke. So 10.10.10.10, which is IP address of spoke 1. We can see first our data going through the hub and then after the spoke. So the next thing, if we're going to implement some sorts of routing, because we do have a LAN connectivity as well, and we want to share the LAN information to hub as well as the spoke so that they come to know the network is exist in order to get proper communication. So obviously once we created dynamic multi-point tunnel, now the next task is we're going to propagate our LAN information to the spokes or spokes to the hub. So configure terminal router enhance IGRP autonomous system 1 and network 10.10.10.0 0.0.0.255 no auto summary out all router. Now we can see we do have do so IP OSPF, sorry, not OSPF, IP enhance IGRP neighbor. So hub has two neighbor, which is 10.10.20 and 10.10.10. But if we're going to see on spokes, we have single neighbor because it is like a frame relay hub and spokes configuration. In frame relay, one router going to hub work as a hub in rest of spoke. So spoke going to form neighbor adjacency directly to the hub but not directly to the spokes. Similarly, we have another problem. We cannot share the LAN information from one spokes to another spokes because logically we connected to the single interface and split horizon going to be cause. So whatever network advertised by the spokes 1 going to learn by hub's not going to reverse advertise to the spoke 2 because of the split horizon. In distance vector routing protocol, this is the problem that we know very well, and I think I have already mentioned if we have some sorts of configuration like phase 1, we may face such problem. So in order to fix it, I need to go to the interface tunnel 0 no IP split horizon enhance IGRP 1. So once we execute command, neighbor going to form re-adjacency or going to resync. Now we do have all the route. So on hub, excuse me, do so IP route, which is learned from the enhance IGRP. Excuse me, I think I do not have added my loopback interface. Right. So router enhance IGRP 1 network 192.168.0.0. Likewise, network 192.168.1.0 and network 192.168.2.0. 0. So 1, 2 and 0. Let me check. Do so IP OSP, sorry, IP root, which is learned from the enhanced IGRP. So hub know how to get network 1 and 2. Obviously, spokes know how to get network 0 and 2. So 0 and 1. If we going to disable split horizon, let me verify you. Interface tunnel 0, IP split horizon enhance IGRP1 going to enable. So the problem is, check the routing table. Do so IP root learn by enhance IGRP. Hub has both of network information connected to the both of spokes, but spokes they have only hub network because of the split horizon. So let me use no IP split horizon. Good. The next thing, let's verify the connectivity as well. So I think we do have a connectivity. So do ping 192.168.1. 2.1. My source address is loopback 0. We can see we do have a connectivity. If we're going to perform trace route 192.168.2.1, source interface going to my loopback 0. Again, we're going to send traffic to the hub and then after spokes. Similarly, if we're running another routing protocol like OSPF, again we're going to face some sorts of problem. So let's see. Let's say no router enhance IGRP 1. Okay, we can run static routing. Top of it, either we can also run dynamic. So far we gone through the enhanced IGRP, and let me implement OSPF. Router OSPF 1 network 10.10.10.0 0.0.0.255 area 0. So are they going to form neighbor adjacency or not? The next thing is interface loopback 0 IP OSPF 1 area 0. So I also added my loopback address out every router. And now we can see the neighbor adjacency going up and down, up and down, up and down. Because by default, your tunnel interface going to work as a point to point. But we listening message from both of router. So it should be, your tunnel should be either multi-point or a broadcast interface. So you can change it in order to fix OSPF routing problem on DMVPN. So the interface tunnel 0 out of all router, IP OSPF network is broadcast. So once we created it broadcast, now we have another problem. So suppose now this is broadcast. Now we're going to form DR in BDR selection. Suppose somehow DR going to elect by spoke 1, spoke going to point out to all router that he is working as a DR. So he cannot directly send traffic to the spoke 2 as we know in phase 1 configuration. If I am going to become DR, I will only going to inform to the branch, and I cannot inform to the branch 2 or spoke 2 I should say. Because we know very well DR is a router which going to propagate routing information out every router. So make sure your hub going to become DR in rest of other DR. They are not going to elect as a DR or BDR. In order to do this, what we can do, we can decrease the priority of tunnel interface as a 0, which basically means both spoke not going to elect as a DER in BDR. Then hub going to become DR, which going to propagate the information out all the spokes. So again the problem we have. So interface tunnel 0, IP OSPF priority 0, IP OSPF priority 0. So let's say it may take a little bit time. Do clear IP OSPF process. Yes. They're forcefully going to form re-neighbor adjacency. And it may take a little bit time to fix it. But we know the concept of dynamic multi-point VPN. Once we know the concept of dynamic multi-point VPN, we need to figure out how your routing protocol going to implement. So in enhanced IGRP, there is problem of split horizon. In OSPF, we need to create this interface as a broadcast. If the interface going to the broadcast, the next problem is make sure your hub router going to elect as a DR in rest of other DR. Because by default interface is going to point out point-to-point network. So you need to execute command IP on interface IP OSPF network broadcast, or on hub IP OSPF network multi-point, and rest of two spokes as well. So in my case, I'm not going to do rest of things because this is what we're going to learn, the technology of dynamic VPN. So this is what we need to discuss in phase 1. In phase 1, there is some sorts of problem like we cannot do summarization and default route. Actually summarization and default route allowed from the hub. But the problem is every time when we sending data from one spoke to another spokes, if we have 100 of 10 or thousands of spoke, every time they're going to send traffic to the hub and then after going to redirect to the other spokes. That is what the problem with phase 1. In upcoming video, we're going to discuss about phase 2 and phase 3 configuration.